Okay, it's 2 o'clock, so I'm going to start. And as usual, you need to go to dementi.com or use the QR code. And okay, there is a question. Okay, good afternoon, students. Okay, so today we are going to practice how to implement the regression in the real environment. And also today's lecture is pretty important because I'm going to show you how to participate in Kaggle competition. So of course, I'm going to tell you how to participate in the Kaggle competition again and again. But once you understand the way you are involved in the Kaggle competition earlier, then you will have a lot of chance to practice yourself before our actual competition. So if you have any questions before we start, please let me know. Okay. So today I'm going to start with the TensorFlow. So first we need to go to a website called the TensorFlow. So open your browser and type the tensorflow.org. Then you will see the same screen as mine. And I strongly encourage you to participate today with your computer, with your browser, because once we finish our regression in the TensorFlow, then we are going to the very similar thing or the Kaggle competition. And Kaggle competition, so I made the example competition today, so I'm going to show you how to participate in the example competition. So go to the TensorFlow, and then here is a get started with TensorFlow. Just press the button, and you can see the 2 buttons here. One is tutorials, the other one is guide. And since the tutorials are the easier part, we are going to start with the tutorials. So once you are inside the tutorial website, and on your left-hand side, there are lots of menus. You can see lots of different things. And this section is divided into 2 different pieces. One is for the beginner, the other one is for advanced. But okay, so we are gonna start with the beginner and ML basics with Keras. And there are several examples. And today I'm going to talk about the regression, because we already talked about the basic concepts of the regression and how can we implement the regression with just a NumPy. But today we are going to use the TensorFlow to implement the regression. So I hope you can follow me so far. So first go to the tensorflow.org and then press the get started button. And there are 2 menus. So one is the tutorial that we are going to use today. So once you are inside the tutorial menu, there is a beginner and ML Basic with Keras. And under that menu, there is a regression part. So once you press the regression part, you will see the same thing as mine. So it's about the basic regression and predict fuel efficiency. So instead of going through the web page, I'm going to use the Google Colab. So here you see 3 different buttons. So the leftmost one, the Run in Google Colab. So when you press it, it will automatically open the another tab. And we are in the Google Colab environment. So let me go back to the previous tab. And this is just the home page. So everything is just the static part. But once you go inside the Google Colab, you can edit your programs and you can run your programs. But before we start, let me make a copy of this one, because once you practice on the Colab, this original Colab is from the Google, you cannot save it. So you might lose all your work. So go to the file menu, and then there is a menu, save a copy to your drive. Then it will make another tab. So I'm going to, I'm going to use my copy. But everything is exactly the same. So let me close okay, before I close the left-hand side, so let's read some parts. So it's about the basic regression, predict the fuel efficiency. And first we need a data to work with. And then, so this Colab will show you how to get the data and how to clean the data and something like that. And then it's basically about the linear regression. So there are 2 parts. The one is the linear regression, and the other one is a DNN regression. And DNN stands for deep neural network. And you don't have to worry about the terminology at this point, because once you practice with this Colab, and you will be very comfortable with the terminologies. And then, there are some other chapters, the sections for performance and something like that. But everything is basically on right-hand side. So I'm going to close it. But if you wanted to see the previous one, the previous menu again, then here is an icon on your left-hand side. So this one gives you the contents, and you can close it, and you can search. And what is this? Yeah, this is some other useful help. Yeah, the useful help, but we don't need it. So in order to start, I need to connect this website to the Google virtual machine. So I'm going to press the connect. And it says allocating and connecting. Okay, so let's read together. In a regression problem, we aim to predict the output of a continuous value like a price or a probability. So contrast this with a classification problem where we aim to select a class from a list of classes. So for example, you have to classify whether it is a cat or a dog. That kind of thing is called a classification problem. But here we are going to predict a continuous value. And this kind of value is called a regression problem. And this notebook used the classic auto-MPG data set and build a model to predict the fuel efficiency in late 70s and early 90s automobiles. So MPG stands for mileage per gasoline. I mean, mileage per gallon. Yeah, so in your terminology, it's a 가성비. So here we are going to collect the data about a automobile, and so it has how much uh, uh, so how many cylinders it has, or what is the horsepower, and based on these characteristics, we are going to predict the MPG of a particular automobile. So this is basically the regression problem. So to do this, we'll provide a model with a description of many automobiles from that time period. And this description includes attributes like the cylinders, displacement, horsepower, and weight. So before we start, we are going to install a new package. And actually, we don't need this one because the Colab also already have the Seaborn here, but just since we are practicing, so just run the code. So do you remember how to run the code? So press while button and press the return. Then it collects the data from the outside and then try to install in your environment. And then the next cell says, I'm going to import matplotlib, and I'm going to import NumPy, pandas, and Seaborn. And then the last part is make your NumPy print out easier to read. So actually, it's just small options. So even if you don't understand what it means, it doesn't matter because it just print out the NumPy array more readable. So we just execute it. And then we are going to import TensorFlow things. So it imports the TensorFlow, and from the TensorFlow, import keras, layers, and some pre-processing layers, which I'm going to explain what it means, and then print the TensorFlow version, and the version is 2.3.0. So that is the current version of the TensorFlow. And they said the dataset is available from this website. So we can download this website, but before we download it, so I'm going to show you how to see this data set. So I made a copy of this one, and then go to another tab and paste it, and it says, it's some URL, HTTP something, and then it will automatically download your data into your computer. But the last one is .data, so it does not have any specific, it does not correspond to our usual file format, but the one way to see what's inside is just a click and then put it in the tab. Then it will show you the data set here. And you can see, yeah, there are lots of numbers. We don't know what it means yet. And there are some descriptions because it's about a car. It's about a cars. It's a Chevrolet. I don't know. It's Malibu. It's Buick, and some. So I don't know much about the cars. So we just pretend okay, there is a data set. So the URL is just a string that contains the location of the data set. And then here we made column names because the original data set does not have a column name. So we put the column names on top of these data set. So it's MPG, cylinder, displacement, horsepower, weight, acceleration, model year, and origin. And we all know how to use the PD read CSV. and then provide some more informations. And, and there are lots of options written here, but actually I don't know the full options here. So if I place my cursor on read.csv, it shows me lots of options here. And there are so many options, and we do not know how to use them all, but the TensorFlow people made these options for us. So we just run it. And then before we see what's inside, let me make another code between these two cells. And we can see what's in raw data set. This is Panda's data frame. So the content is basically same as this one, but you can see the difference because it has a column name and it does not have the last parts, the description of cars, because that's because they made these options. So you don't have to worry about the options. Anyway, yeah, we get the data set. And then before so usually the people who deals with the data set always make a copy at first, because we don't want to distort the original data set. So here, raw data dot copy, and make a copy and then rename it as data set. And then data set dot tail shows the last part of your data set. So it shows me the last 5 rows, which is exactly the same as the previous one. But here, the raw data set is somewhere, and we make a copy, and then we are going to change the copied version so that the original version does not be affected by our change. And one of the problem with the data set is that probably it has a lot of missing values. So one way to see how many missing values it has is to use some code. So we are dealing with the data set. And we cannot see the data set between the 4th and 397. So instead of looking at the data set by your eyes, we can use some command. So it's isNA. So isNA means, is it NA, and NA means not available. So once you execute this command, it will give you a lot of true and false value. So NA means not available. So if you ask, yeah, something is not available, then the first cell, the MPG0, is false because the first number is available. So when you ask your computer is not available, then it's no, it is available. Then how can we see, and actually there is some true values inside this data frame. So in order to see that, we can use .sum. And remember that in Python, the false is 0 and true is 1. So if everything is false in some column, and if you add all them up, then the number will be 0 because the false is 0, 0, 0, 0. But if there is some true value, then that column, if you add all the values in that column, then you will get some number. So you will see MPG is all 0 and cylinder is all 0, but there is a problem, the horsepower. and it says it's 6. That means there are 6 ones. So how can you deal with these missing values? And there are several ways to deal with the missing values. And if you did your homework correctly, then you already know how to deal with all the missing values. But here, the TensorFlow in this tutorial use a very simple technique. That means just to drop the missing value. So that's the command for the drop the missing value is drop NA. So drop NA, remove missing values. So if there is one missing value in a row, then just drop all the row with missing values. And we can do that because there are only 6 missing values. If there are too many missing values, and if you apply the drop NA, then most of your data will be gone. But for this tutorial, and they said drop those rows to keep this initial tutorial simple. So it is not a good practice to drop the whole rows, but for simplicity, we just drop drop NA values. And once you drop the NA values, then you can apply the same code here. Now, since we apply the drop NA to missing values, you will not see any missing values here. So now everything is 0. That means every values are available. So let's take a look at the data set again. So MPG is okay, and that is going to be a variable we are going to predict. But right now, yeah, it's okay. And cylinder is probably it means the number of cylinders in a car. And displacement, I don't know what it means, but it's some value. And horsepower is another value, weight, and acceleration, and model year. But the problem here is the origin. So what do we mean by origin? Actually, the origin column is actually categorical data, not numeric data. So it has 3 different values, the 1, 2, and 3. And if you go back to the original data set, you can see the origin is here, it's 1, and some value is 3. So what is 3? It's Toyota Corona. And number 2 is Volkswagen. And number 2 here is Audi, it's Saab, and BMW. And number 1 is Ford, Chevy, Dodge. So you can see that number 1 is a car from the United States. And number 2 means a car from the Europe. And number 3 means car from Japan. So actually 1, 2, 3 is not the one that we want. And of course that origin might affect the mileage per gallon. So we need to include in our model. And they showed a little technique how to deal with this situation. So this is the origin column. And in the origin column, there are 3 different values, 1, 2, or 3. So here, dataset origin selects the column with the name origin, and then apply a certain function called a map. And then map function, map is a mapping. So if the number is 1, and replace that number with the USA. If the number is 2, replace that number with the string Europe. And if the number is 3, then replace that number with a string Japan to the origin column, and then save it again to the origin column. So once you do this, well, there is some warnings, but I think it's okay. So let me see the data set again. Then now you see the origin column has been changed. So instead of number 1, 2, and 3, we have USA, Europe, and between these two, there are some Japans. Yeah, something like this one. So the reason they replaced the number into a string is to use pandas special function, get dummies. So get dummies says it converts categorical variable into dummy variables. So what it mean by dummy variable? So I'm going to explain it with a whiteboard. Okay, so we have USA, and we have Europe, and we have Japan. And it was originally just a 1, 2, and 3. And actually, we can use this 1, 2, 3 in our regression model directly. But the problem with that kind of data is that it does not, so for example, here, number 2 does not mean that it is twice as number 1. It's just Europe, and number 1 is just USA. So the Japan should not be just 3 times bigger than the USA. So how can you deal with this kind of situation is to use a special use a technique called the dummy variable. So when USA is true, it's 0 and all the other 1. When USA is true, it's 1 and all the other column is 0. If the Europe is true, then it is 1, all the others are 0. And if Japan is true, then it's 1, all the others are 0. So we can make this kind of representations. And then the better property of this representation is that the 1, 0, 0 is not, so if you multiply any number, you cannot get the second one or third one. But here, if you multiply 2 here, you will get this one. If you multiply 3, and you will get this one. But this is this representation does not have that kind of meaning. So that's called in computer science, it's called the one-hot encoding. And in statistics, its name is a dummy variable, but in computer science, the people call it the one-hot encoding. And you can do it by hand. So when you see the USA, you can make 1, 0, 0, but it's too tedious. And how can you make that one? It's get dummy. So apply this get dummy function to our data set, and then save it to the same name. Then it will be replaced by these last 3 columns. So you see, it was origin, so USA, Japan, and Europe, but now it has Europe, Japan, and USA. So that's why we change the number 1, 2, 3 to their corresponding strings, and then that string can be used as the column name. So when some row is from Europe, then it's 1, and all the others are 0. And Japan, you cannot see the Japan here, but there are some 1 value above here, and USA, yeah. Okay, so that's the one way to deal with this kind of situations. And then we know we need to split the data. So one is for the training to our model, and then in order to test how good our model is, we need another test data set. So we are going to split our data set into train and test. And there is also a function. So the data set sample, and the fraction is 80%. So that means from the data set, the whole data set, take 80% the sample and then save it to another variable named train data set. And then once we have the 80% of our train data set, then this train data set has a row, the index numbers, and drop that index number from the original data set, and that's the remaining data set. And we will call that remaining data set as test data set. So this is so once you select the 80% from the original data set, then the rest of 20% will be automatically in the test data set. So this is the way they split these two data sets. So you can see the train data set. If you see the train data set, the row numbers are not in order because we just select the 80% from the original data set. And then if you change it to a test data set, then test data set, then the old test data set value is not included in the train data set value. Okay. And they wanted to inspect the data. So I have a quick look at the joint distribution of a few pairs of columns from the training data set. So look at the, so how can we make it? That's why we import the seaborn. The seaborn gives you a very pretty pictures of your data set. So it says it's a pair plot, and we'll see what pair plot means. So this is the actual output of the pair plot. And actually the pair plot is not the, it's not, how would I say? 갑자기 영어가 안 되는데. 페어 플랫이 페어 플랫이 무슨 공식적인 this is not the official name. It's just this package called this kind of plot as pair plot. But you can see what it means. So it has MPG, cylinder, and displacement, height. And on the y-axis, we have the same 4 variables. So on the diagonal is actually, you may think this is the histogram of that variable. So MPG is the histogram of the value in the MPG column. So yeah, it looks like this. And the second one is the cylinder. And you can see the cylinder is actually yeah, we can guess the number of cylinder must be integers. So it might be 4, 6, or 8. So the histogram looks like this. And displacement is this, and weight is this. So diagonal part is just the histogram of each data set, each column names. But the reason why we call this one as the pair plot is that you can make a plot between MPG and cylinder. And you can see some trend. So if you have a lot of cylinders, your mileage per gasoline is decreasing. So you can see that kind of relationships. So this is good for inspecting your data set before we actually run the code, because by looking at this one, you will see at least you will see the direction of your coefficient, because it should be negative and it should be positive, and that kind of information might be useful for later. So we are going to see the actual statistics. So MPG has 314 values. Its mean value is this one. Its standard deviation is this one. This is the minimum, and this is the maximum, and this is the median, and some other quantile points. And you can see, all this kind of information here. And you can also see the Europe is not the continuous value, but you can see this is correct because the minimum is 0 and maximum is 1. So the Europe column, the older value is just 1 or 0. And you can see that the 17%, actually 17.8% of your data set is from Europe, and you can see 19.7 is from Japan, and 62% is from USA by just looking at the average. Okay, now we are going to, so our goal is to predict the, okay, let me see the data set again. Train data set is this. So we are going to predict the mile per MPG with the help of the cylinder displacement, horsepower, weight, acceleration, model year, Europe, Japan, and USA. So our MPG is going to be our Y, the labels. So we are going to take that output out of our data set. So before we go, so first make a copy of the train data set and then name it as train features. So at this point, the train features also has a column named MPG. And test data set, make a copy of the test data set and then put it in a test features. So at this point, the train data set has MPG, and test data train features has an MPG column, and test features also has an MPG column. But once we apply this code, the pop means just select that column and then remove that column from the original one and then put it into another variable. So once you apply the pop, and then you have to write the name of the column, and then it will and then save that column into train labels, and then from the test features and take that MPG column and save it to test labels. So once we execute this one, you can see the train features does not have MPG column, but train labels has all the values of the MPG. So the first value is 28. So you can see it was 28 here and 22 and 22. So you can successfully split your data. You can take out your label data, and which is your Y, and the train feature has all your axes. And then before we go, so this is all the data processing. So you get the data and check whether there are missing values and make the categorical variable into the one hot encoding variables, and then take out your Y outside of your DX data set, and then we are going to do something. So from our train data set, we can see the mean and standard deviation of all these numbers. And it said it is always a good practice to normalize features that use different scales and range. So as you can see, the MPG, we don't have to normalize the MPG because that's the value we are going to predict. But for cylinders or displacement, horsepower, their scales are, their mean and their variance are all different. So it says it's a good practice to normalize features. So one reason that the reason why this is important is that the features are multiplied by model weight. So the scale of the output and the scale of the gradient are affected by the scale of the input. So what it means is that if you think about your coefficients and your original data set is too big, then the coefficients times your variable will be big because the original data set is big. But if your data, the original value is small, then the whole multiplication is small. But that should not affect your direction of the optimal point. So instead of using the big numbers and the small numbers in the original term, we are going to normalize it. So normalize it means you just subtract the mean from every number and then divide by the standard deviation. Then you will get a number somewhere from -3 from +3. So all the numbers are well scaled and the mean value is around 0. And you can do it by hand one by one for your cylinder. Take out the mean and then divide by the standard deviation. But the TensorFlow gives you a much better way. So that is the normalization layer. So how can you use this normalization layer? And actually, this is the new feature of the TensorFlow. So let me go back from at the beginning. And we are going to use the pre-processing. And you can see here, it's from TensorFlow Keras layers experimental. So usually when they develop a new thing, they put it in the experimental category. And then once they are well stabilized, then that module will be moved to the appropriate places like layers. But here the normalization layer was introduced before a month ago. So I did not know that it was here, uh, but we are going to use it because it is in the tutorial. So this is just a given. So we first define our layer like this, and then name it as a normalizer, and then apply the adapt method to normalizer. And this is your data set. So for me, it's not easy to understand this one because the usual layer has a very similar syntax, but this is the experimental feature, so they just want me to follow this procedure. So first, define normalization layer, and then provide the information. Then that because I provide all the training features to the normalizer, it can calculate the mean, and this mean is the same as we calculated here. But this normalization layer remembers the mean of each column and standard deviation of each column. So when the layer is called, it returns the input data with each feature independently normalized. So let's see what is the result. So the first example here is the original data set. And then, as you can see, the first number has its own mean and standard deviation. The second one has its own mean and standard deviation. But since the normalization layer knows the mean and variance of each one, the normalized one is here. So the 4 has been changed to this number, 90 is this number, 75 is this number. And you can see the all numbers are very close to zeros, and actually it's probably from -3, from +3. So this is the one feature that was introduced recently. So we can use this one. Oh, it's 250. Okay, let's take a break for 10 minutes, and we are going to start at 3 o'clock. And I'm going to show you how to do the linear regression from here. And then I'm going to show you how to apply all this technique to the Kaggle competitions, because I already prepared the sample Kaggle competition today. So don't forget to come back at 3. And I want you to go the Kaggle. Okay, I put the URL on the chat. So it's kaggle.com/c/kaggle-practice-competition. Then you can find this one. And since I am the host of this competition, so you can see the Kaggle practice competition, Yonsei University. So it should be, you can see the Yonsei University here. And since I'm the host, I can control lots of things, but here there is not much information. And once once you are inside the competition, you should press the My Submission, and there is going to be some button you have that says you have to agree with the terms and conditions of this competition. And in order to participate in this competition, you have to accept it. So if there is any problems, yeah, please let me know, because this is my first hosted competition. I don't know how it will be shown to you. So if there is any problems, please let me know through Mentimeter or the whiteboard. And if you are successful, then please let me know. You can do it, on chat or, okay, there is, there is no My Submission screen for us. Yeah, you have to sign in Kaggle, then, or, maybe the submit predictions. So I don't know which button can be shown to you, but anyway, you have to accept the terms and conditions of these competitions. So anyone who succeed in accepting the terms and conditions? Oh, okay. Join the competition. Oh, okay, So the another student, send me a chat. So before you press the My Submission, you have to first click on Join Competition. Please, do it by yourself, because this is exactly the same way you participate in the real participation, the real competition. Oh, okay, I think students can successfully join in. So once you are inside, and in the real competition, there are lots of descriptions, and there are lots of evaluation matrix. The evaluation matrix, and you will see the other notebook and discussion topics. But since this is the our competition, I made the due date next week, but I hope you have to do it today, and you can go to the data section, and you should see the train data set. And this is exactly the same thing as we are doing right now. And then here is a test data set. And test data set does not have the MPG, because I intentionally delete the the MPG from the test data set. And this is the sample CSV. So basically what you are going to do in this competition is to make a submission, a CSV, something like this one, the ID and predicted value, and then submit to this competition. Then I hope it will automatically check your answer and show you the rank. So this is so if you have any problems, please let me know. Oh, of course, for the final project, I have not decided my yet, but I think I'm going to make a competition for you. So I'm going to make my own problem, and then let you join. Let you guys join to my competition and submit the answers. So that's what I am planning to do. So this is some sort of practice for me. Now, once you are successful, go to the notebooks and then press the new notebook. Then it will show you something like this. So you are going to use the Python language, and your notebook is, you have two different types, but the notebook is fine. So create. Okay, then it shows a name, but this name is quite arbitrary. So your name should be different from mine because they want their notebook to be unique to every notebook. But you can definitely see something like this. So this is not QRM, but this one is provided by the Kaggle. And this, you may think this is another collab because you can shift enter to run the cell. So the first one, there are lots of comments, but the important part is, import the NumPy and import the Panda. And here, there are some more complicated things, but don't worry about it because it just shows you what kind of data set is given to you. So it's the sample CSV test, the CSV train the CSV is here. So I'm going to read the data set and I'm going to call it a DF and PD read CSV, and the data set is given, the data set given in the competition is always available within this notebook because you joined in this competition. The data set in the competition will be shown automatically here. So select this one, and then we are going to read it. Read, and then see what's inside. So then you should be able to see this one. And you see the similar things because I just, since this is just a practice question, the practice competition, I just did the same thing for the data for the regression problems. So it is already made for you. So you don't have to worry about the Europe column, Japan column, or USA columns. So this is the data that are given. And what you have to do is to make a prediction based on, for the test data set. And let me show you how to get your test data set. So everything is same except the test.csv. So the first one is the train.csv. So it contains a column of MPG. But for the second one, it's for the test, and it does not contain the MPG column. So what you have to do is to make a model and train your model based on train.csv, and then make a prediction for the test data set, and then make the prediction, and then make it to a file and submit to submit your final result to the competition. So before we go into the hardest part, let me show you how to make your submission file. So for your submission file, you need two columns, and usually it is given in the sample format. So let me read the sample. So just get sample. Okay, so this is the required format. So the first column should be the ID, because you see there is a ID in the test data set. Oh, I think, yeah, I have a. Where do we get the CSV link? No, you don't need the CSV link for this competition, because once you accept the rules of this competition, the CSV file is already inside your competition. So what you have to do is just read the CSV file from your Kaggle environment. Okay, so this is the required format. But since this DF is not, this is the data frame, so you have to save it to CSV file in order to submit. So the code is to CSV and submission submission dot CSV, and one important part is index is false. And then run it. Then you will get the submission.csv file saved in your notebook. And this is the important part from now. So once, okay, we do not have a model. We just take the input and see what's inside. And I just to show you how to submit your final answer. Of course, you have to make your model to predict something, but this is just an example. So once you think you are finished, here is Save Version button on top right, and press it. And there are two types of save. So take save and run all, commit, and save. And then everything will be saved, and it is doing something. So just wait. Okay, now it is done. Now I can press the view button. Then this is the just the saved version of your code. And then if you go down, somewhere around the output section, there is a submit button. So press this submit button. And then it says submit to competition, and you have 10 submissions remaining today. So I made the number of competitions. I made the number of the limit up to 10. So you can submit 10 times a day. And then this is my alpha file, so submit. And then if you are success, then you can see your view my submission. And submission is complete. And you can see all your previous submissions. And I made this one yesterday, and my first attempt was fail. So it was an error. But I hope, you can do it right. And for some reason, I don't see my positions, but okay, you are good. Yeah, now you are on the list. So there are 4 students who successfully submit their answer. And this is the way, I was too worried about this one, because I'm not sure, because I am the host, and even if I submit my answer, it is not calculated. The answer is not calculated. But I see, you guys are doing right. And this is, what we are going to do in our real competition. Okay. So will the final project be the competition only among the class members? Yeah, I think so. Okay, I will show you again. So first, you have to find your competition and then go to the notebook. And since I have my notebook here, I can see my notebook. And I hope you have successfully submit your notebook. But okay, this is the original one, and you can see there is a version. So every time you make the modification to your notebook and then save it again, then the version will be goes up or one up and 2 and 3, 4. And then you will get this one. And you can see here is here is my notebook contents. And at the bottom, you see the input information. And then here is the output information. And press the submit button. And then you can select which version you wanted to use, or you can use what notebook do you want to use, and then press the submit. Oh yeah, 9 students are successful. And if you don't know how to make the submission file, this is the answer. So first, you have to read the sample file. So of course, just putting your the sample submission file does not give you a high score, but this is just the example. So read the sample.csv and save it to here, and index is false. And then once you do that, save your version and then go to the output area, and then there is a submit button. And once you submit your answer, then your answer will be your submission will be calculated. And then based on the calculation, you will be ranked. But since we are all the same score, because you guys submit exactly the same thing. So from now on, I'm going to show you how to improve your score. So we are going to do, going back to the Colab. Okay, let me recall what we submit. We submit exactly the same numbers. So I don't, well, this is the one solution. So if you have to predict something, so you don't care about all your input variables, so you just, okay, my prediction is 10, 10, 10, 10, 10, 10, 10. But actual answer will be different from 10. So the Kaggle, the competition calculates the difference between the real answer and your the stupid guess, and take the difference and then add them up and divide by the number of the data points, and then that is the value here. So in this competition, our goal is to minimize this value here. So the one way is to use the linear regression. So we are going to start from the just one variable linear regression. So start with a single variable linear regression to predict MPG from horsepower. And training a model with Keras typically starts by defining the model architecture. So in this case, we are going to use the Keras sequential model. And this model represents the sequence steps. In this case, there are 2 steps. So first, we are going to normalize our horsepower input, and then apply a linear transformation to produce one output using layers.dense. I think, yeah, I'm going to pronounce our competition just after the midterm. So you will have about 6 or 7 weeks to prepare your final submission. Okay, so yeah, apply a linear transformation to produce output here. So basically, what we need is just copy this part and put it to our notebook. So for those of you who are successfully saved this one, okay, let's start from the beginning again. So read it, and we read the train.csv, but this train.csv has MPG and all the other one together. So I think, yeah, I need to add a code. So this one is from the TensorFlow, but the variable names and some other things are different. So we have to make a modification. Okay, so how can I modify my one? So I think, yeah, I need this part. Okay, there are some more things. Could you show me the code again? I could not catch it from the very first. Okay, I will. I'm gonna see your rank. So if you have not catched yet, it's okay, because yeah, just follow this part. So first we need the data set, and then save it to DF. And then I'm gonna, rewrite from here. So my train features is df.copy. And my train labels is train features pop MPG. Okay, I think I need only these two. Let me see. Okay, let's see, it's train features. I think this ID is unnecessary, so maybe I can pop the ID also. Okay, and then let me see the train features again. Okay, this is the same format. Okay, this is the train format. Okay, now I can use this code. Oh, it's train features. Oh, okay, so here I'm going to take the horsepower only, and then save it to horsepower, and we are going to pre-process our normalization layer, and then put it here. The name pro-processing is not defined. Yeah, it is not defined because I did not import this one. So let me go back. And I did not import the TensorFlow. So I'm going to import it. And okay, let me add this one. Yeah, the Kaggle TensorFlow version is also 2.3, so it's fine. Okay, this is done. Yeah, there is no error. So we made a horsepower normalizer. And then horsepower normalizer, I did it. And then build a sequential model. So let me build a model, just copy and paste it here. So it's called TF Keras sequential, and there is a horsepower normalizer, which is defined just before. And then layers dense unit 1. And the whole model's name is horsepower model. And then we are going to see what's inside. So this is our model. So it has, it has a normalization layer with 3 parameters. Yeah, just why we have 3 parameters. And here is a dense layer, and it has 2 parameters. So for the dense layer, why do we have 2 parameters? Is that we are going to use this one as our model. So the m, the slope is is a parameter, and b is also a parameter to be estimated to make this model. So there are 2. And why normalization has 3 parameters? Because it has mean, standard deviation, and the number of samples. But so the total parameter is 5, but the trainable parameter is just 2, because the mean, variance, and the number of points is for the normalization. So you cannot control, you cannot train those parameters. That's from the input. So we can only train 2 parameters in this model. Okay, so we build the model, and then we are going to see it really gives me a value. So just copy this one and see what it will predict. So horsepower model is a model we predict, the model we have built, and use the predict the method to horsepower up to 10 points. And it gives me some values. So of course, this value is terribly wrong because we did not train the model. So it's just sort of a random numbers, but once we are trained, we are pretty sure it will predict the 10 numbers. So this one is for the first prediction, this one is the second prediction, and so on. The questions. I will make it later because I'm still working on it. So yeah, you can. Yeah, but so that's why I want you to follow me so closely. So if you lost one part, then you cannot catch up. But of course, yeah, you can do it later by just my shared notebook. but you have to do it. You should be able to do it by yourself from the whole new notebooks. But yeah, anyway, yeah, I will share my one. Let me see. I can share my one here right now. Okay, I can share. I can make it public. I can make it public. Yeah. Then I think yeah, you can go to the go. And compete and hosted. I don't know. Yeah, how can I add my? Anyway, yeah, I made it public, so I'm going to put it in the chat. So maybe yeah, you can share my one. Okay, let me yeah, start from the very beginning. So the first cell, you don't have to worry about the first cell because it is made automatically, and it shows you 3 CSV file. So just copy the train.csv and then put it in the read CSV string here, and then save it as df. Okay, then you are going to get all of this. Okay. Then maybe I can start from the importing TensorFlow first. So from the regression QRM, I run the first cell and then add the code and import the TensorFlow. Here you can import the TensorFlow and then read the train data set and then make a copy. And I'm going to use the train features and train labels because the TensorFlow collab use those names. So I just make a copy. And then since I don't need the ID column, I can pop and see what's inside. And it's this one. And since I already imported this one, I don't need this one. So I just delete it. And then we define a normalizer and then make a model. Okay. And then see what we can get. Okay, so the numbers are different, but yeah, it's okay. So, okay, let me go slowly here. So you were not able to run the horsepower code. It was additional import. Okay, I'm going to copy all my code one by one in the chat. And I wanted to see, yeah. you can do the same thing as mine. Okay, this is all I have so far. And from I don't need these things. Okay, so I made all the copies. So you just copy your my chat to your notebook, and then you should be see. The pre-processing is not defined. What's the error that I had? I tried to run the horsepower code. Okay, so that was here. You need this part. From TensorFlow Keras experimental, you need pre-processing. Okay, that's good. Okay, so this is the horsepower model, and we are going to do build our. We already have built our model, and we need to compile and train. So the compile means to provide some more information. So the code. So horsepower model dot compile, and we are going to use the TF Keras optimizer Adam with the running rate 0.0. At this point, this is not important. So it's just a name, and the loss is the mean absolute error. And then run it. So I'm going to make a copy and then put it in a chat so that you can make your own. And then we are going to train it. And it's just 3 seconds. So when we read this part, I'm going to show you. I'm going to make a copy to you. It's a train horse, it's a horsepower model fit. And this is our X data, train features horsepower. And this is our Y data. And number of epochs is 100. And verbose is 0. That means we don't want to see all the details of the output. And there is some validation split, and we don't care right here, right now here. You still have a key error MPG. That's because you did not something wrong with this one because okay, where is the MPG? MPG is shown just once here. Well, I don't know. Okay, so I'm going to save my notebook and make a shareable version, and then you can. So can yeah. Okay, right now I'm gonna make a save. Okay, I can view. Yeah, it's already here. So okay, let's take a 10 minutes break, and then I don't think I can finish all the regression part, but yeah, I can definitely show you just the one variable regression, and we are back at 4 o'clock, but uh, for those of you who have not succeeded in submission and try to submit and share use my shared version of the notebook and try to submit your and I will be here. So if you have any questions, please let me know. I'm going to help you. And for those who uh, are comfortable so far, take just a 10 minute break, and then we're gonna start again from 4 o'clock. 4 o'clock. So I'm going to the answer. Okay. Uh, So one of the students says the PD read CSV. It keeps saying that I have attribute error, but when I submit it, it says I have succeeded. Okay, your problem is you submit the wrong one because the shared version of my notebook has a very at the end. Uh, it automatically make a submission file, which is not related to the previous one. So it has an answer, but you have to do it from the very top. So even if you succeeded your submission, and that does not mean you are successful. Okay, so we are going to first, you have to accept the competitions, and we are so just to wait. We are going to do our first regression, and then I'm going to show you how to submit your answer. So this is exactly okay because it used some sort of a random number. So my one is different from yours. So that's absolutely normal. Okay. So that's good. Okay, so far we have 18 students, but yeah, your scores are exactly the same because that's the sample submission. So we are going to make a new submission with my notebook. So the first cell is given, and then we import Keras libraries. And then, yeah, one of the students has a problem with that. So be careful with it's read underscore CSV, and your URL should be exactly the same as the output. So just, yeah, a copy the Kaggle input, Kaggle practice competition train.csv, and then make sure that you have just one. Actually, it doesn't matter. Yeah, it has just one quote or two quotes. Then you should be able to see this one, and then we make a copy, and then we drop the ID and check our data set is correct. And then from here, we just make a copy from the TensorFlow notebook, the TensorFlow collab, and then make a model and prediction. And my prediction is different from yours. Yeah, that's normal. And then we compile our model and then train it. Okay, so I just trained the model, but I did not tell my model to predict. So in order to predict, I need to add a code here. And for my test set, I need to make I need to read the test.csv. So I copy this string. And then it's test. It's test features. PD. Oh, wait, it's not. Okay, just yeah, read it as df. PD read CSV. Okay, this is our actually, yeah, you may think, yeah, this is the problem you have to solve. Okay, let me go back to here. Okay, first, we before we make the prediction, we wanted to see how good my model is. So as you can see here, once we finish our fit, we save all the results to a variable called a history. So you can see the history that history is we make a new data frame and save it as a hist, and you can see we iterate 100 times. So the loss every time the loss is getting not always getting smaller, but yeah, it's getting better. And then make some plot. I don't want to go to the plot because we did not import the map plot here. Okay, so just how to make a prediction. Okay, here is the prediction part. Oh, it's evaluate part. Oh, okay, here is a predict. Horsepower model predict, and my X is this one, DF horsepower. So let me try DF horsepower. Okay, let me see what's here. Yeah, I have my prediction for the test data set. So I need to make a submission file. But since the numbers are exactly the same, probably I can first get the sample or CSV. So it's DF is PD read CSV. What's the name? Sample CSV. So I read this one, but I wanted to change the predicted part as my y to my y value. So I can say the predicted to be y. Okay, let me see my DF. Okay. Now it's the ID is the same, but I put my predicted value here. Now since the name is DF, I can run this one again, df dot to CSV, and index is false. And I think here I'm done. So I want to save it. Okay, yeah, the students who asked me to how to submit your notebook. So yeah, watch it carefully. First, you have to save your version. And actually, I don't know the difference between these two, but the latter one is Oh, it's best for sharing. Okay, anyway, yeah, I saved. Then it saved my notebook and then run from the very first top to the bottom. Okay, I have a question. Okay, you said the y is not defined because you missed something here because uh, in order to put the y, yeah, you should have this one. So the y is the predicted value. So before you put your y inside your submission file, yeah, you have uh, make a prediction and then save it to y. Okay, so I wanna see my version. And then, okay, this is the version and go to viewer. Okay, I think, yeah, everything is all right. And then at the end of the notebook, you have the input section and you have the output section. And you may notice that the predicted value is different from the previous one. Yeah, previous one, we just take the sample CSV and all the values are all 10. But now we predict our value and I'm going to submit. Okay, so my notebook version 3 and I'm going to submit and view my submission. And my submission is complete, but still I cannot see. Okay, yeah. The first of all, the score is much better. So previously we have 14 something, but now we just use the one variable to predict, but it's much better. So I want to see, yeah, there are lots of students, yeah. So you may see, even if we use the same model, the scores are a little bit different, and that's due to the randomness. But it's on your luck. Uh, how can you get the two predict columns? I think probably the spells are different, or just delete your data frame and then read the sample again, and then use the, so I mean do it again. So read the sample.csv and then put, oh yeah, the what, okay, I can see why you have the different one. To spell it correctly, it has the this, the capital P value, the capital P. So basically, yeah, you have to read the sample CSV and then put your predictive Y to a correct name, and then you will get a new DF. And then save it to submission.csv, and then save it, and then submit your file. Okay, in order to submit, you have to save your notebook here, the save version. And once you are done, you can see the go to viewer. And at the end of your notebook, the first section is the input section. The second one is the output section. And before you submit, you can see the actual values of your submission. And then submit, and submit, and you are done. And view my submission. And I got the same score, because this is actually the same answer. And I can see, yeah, how many of you. Okay, so 10 students. That's good. And we have total 23. Yeah, I think, yeah, this is pretty good. So at least 23 students can submit, and out of them, the 10 students were able to make a prediction. So for example, if this is not your real competition, but if it were your real competition, how can I make a grade? Right now we have 56 students, yeah, out of 100, half are here, and about the less than half are submitted. So if you submit your answer to the competition, you are guaranteed to have C+, even if your answer is below this benchmark. And if you fail to submit your answer to the competition, then you will get an F. So if it were our submission, I will give these students C+. And then you, or the first 10 students are guaranteed in the, say, A or B region. And since we use the same program, yeah, I cannot yet distinguish all these students. So probably if this is the real case, then I will give you the 10 students or A+. Sure, yeah. But I think, yeah, actually the, is it different? I think, yeah, this is the same URL as before. But anyway, oh, the lower the better, because in this case, the score is mean absolute error. So error, for the error, yeah, we want to have the smaller error. So this is, oh, this is the previous version, yeah. So the mean absolute error, the smaller, the better. Yeah, lower the better. You didn't understand the grading. Here is a benchmark. And the benchmark is the minimum. So probably if you predict everything as the same number, then but you submit, then if this is the real competition, then these students are get C plus. And if you fail to submit your answer, then you will get an F. And above the benchmark, you are A or B zone. But in this case, they are all good. In this case, so this is the previous one again. Yeah, the 11 students, yeah, they are all A plus. That's it. Yeah, I got the same error before when I first submit. So there may be something wrong with your code. So please see the shared version of the notebook, and then yeah, you can just modify and see. Yeah, the unexpected column. Yeah, that's the if your column name is different from the required one, then that's the error you can get. Yeah. The usual competition takes 2 submissions per day, but in this competition for practice, yeah, I admit 10 submissions per day. So you can try 10 times, and then tomorrow you can do another 10 times, and then your score will be based on the best one. So I think that's enough for today, but the next week is a midterm. So instead of having a lecture, I recommend you to improve your current competition. How can you improve? Just to read the TensorFlow code, the Colab, and you can see if you use the multiple input, your score will be increased. I mean, the error will be lowered. And if you use the DNN regression, it's getting much more better. So I think this is a good exercise for your competition, the first the exercise competition. And I think this is a good chance to learn and how to do the regression. I'm going to use my own competition. And this is going to be very similar. The final competition is going to be very similar to this one, but a little bit much more complicated because we just use all the numbers, but I can ask you to use some the text things and your model is going to be a real is going to be a real is going to be more complicated than this simple regression, but the basic idea is the same. The collab link is is on the TensorFlow. Once you go inside the TensorFlow, yeah, there is a button run in Google Colab. Then you will get this one. So I don't have to share this Colab here. Yeah. Yeah, there will be no problems because uh, you already know enough Python. So, for example, what we did today for the using Python is the read the data, read the CSV file and save it to the copy to another name. Yeah, that kind of things. So you should be familiar with that once you finish your data camp. And then Colab, yeah, we did a little bit of stranger thing today, but uh, you are going to be very comfortable with putting the layer, the dense layer, and how to change the number of layers and how to change the number of node, that kind of thing. You will be very familiar with that, so it will be okay for the final project.